In this video, I will teach you how to quantify protein samples using absorbance at 280 nanometers as measured by UV-vis spectroscopy. In general, quantification refers to the act of determining, indicating, or expressing the quantity or amount of something. In chemistry, the word quantification typically refers to making a precise measurement of sample concentration. This is oftentimes the first step in experimentation on proteins or peptides. Successful quantification gives concentration measurements that can later be used in experimental assays. There are many common methods of protein quantification, such as electrophoresis, fluorescence emission spectroscopy, or colorimetric absorbance assays like the Bradford assay. A280 is one of the simpler methods, and if done properly, can be both time and cost effective. A280 utilizes the relationships established in Beer's law, which suggests that absorbance is related to the properties of the material through which light is traveling. In this equation, A is the absorbance, E is the wavelength-dependent molar absorptivity coefficient, or extinction coefficient, B is the path length, or cuvette length, and C is analyte concentration. This table summarizes the units of each variable that you will use. Aromatic amino acids absorb light at 280 nanometers. Thus, the presence of a tyrosine, tryptophan, or phenylalanine in your sample is necessary to use this method of quantification. Before preparing your sample for measurement, you must determine its extinction coefficient. This can be found by entering the amino acid sequence of your protein into XSpecies ProParam tool. You can also use the following equation. After you determine your extinction coefficient, you can head to the instrument room. Any UV lamp will do the trick, but here are a few examples of ones that I have used for your reference. The first thing you'll want to do is warm up the UV lamp. This can take about 10 to 15 minutes. Also, make sure the absorbance wavelength is set to 280 nanometers. Next, you'll want to calibrate the instrument to zero absorbance. At this point, the cuvette should contain only your buffer. After you blank the instrument, you can add protein solution to the cuvette and measure absorbance. For more accurate results, measure absorbance using the same volume of protein 3 times and take the average. Finally, you can apply Beer's law and calculate concentration. Here's an example. Let's say you want to determine the concentration of a peptide with the following sequence. This is the sequence of the first 14 amino acids in HCTR1, or human copper transport protein. Notice this sequence contains one tyrosine, so by equation 1, the extinction coefficient we would use is 1490. Prepare your sample with 20 microliters of protein and 980 microliters of buffer for a total volume in the cuvette of 1000 microliters or 1 ml. This gives you a dilution ratio of 20 microliters of protein per 1000 microliters of solution. After 3 absorbance readings, your spectra should look similar to this. Say you measure absorbance at 280 nanometers 3 times and find the average of 0.0639. Plugging this into Beer's law, with a path length of 1 centimeter and extinction coefficient of 1490, you get a concentration of 4.3 times 10 to the negative 5 molar. Remember though, this is only the concentration in the cuvette. To find the concentration of your total protein sample, don't forget to multiply by the dilution factor. Doing this gives us a final concentration of 2.14 times 10 to the negative 3 molar, or 2.14 millimolar. Now you're ready to continue with experimentation. Thanks for watching.